This video was sponsored by PCBWay. So there was some concern about the little bits like falling out if you would drop it, or being really easy to fall out, but that's not the case. They're actually in there really tight, so I can show you here. And that is not coming out, but you can actually. In the prior episode of this build series, we took apart this drill, 3D scanned all the components, and 3D modeled and 3D printed a new casing around it. Also added this little wooden component here, which we did with a laser cutter. And the main upgrade we did to it was adding this magnetic bit storage at the top. The idea behind it at first was to make somewhat of a more film-friendly drill, but also improve the bit storage so that I don't lose bits all the time. I didn't think it was too innovative, but if you take it to the next level, like add drill bit storage on this thing, and even more like tool storage on it, maybe make this handle rotatable, so to say, so you can still use it in this configuration, I think that would be pretty cool. So I ordered some of these rosette mounts, and as you can see, there's little teeth on this side and on the other side as well. When you press them together and actually lock it down with some kind of bolt, then they don't move anymore. But then you can unscrew them and then really quickly adjust it, and then you screw it back together and it's tight again. And I also ordered this drill bit set, so I'm curious to see what's inside of here. And so what I really hate about these kits, which I also mentioned in the previous video, is how difficult it is to take the drill bits out and push them back in again as well. So, they come in these little rubber things, or most of them come in these little rubber things, and they're incredibly difficult to pull out. And maybe there's a method for this that I'm just not smart enough to understand or something. But that results in a lot of lost bits because I'm not putting these back into the rubber casing, right? Because I know it's going to be a pain to get them out again. And if you make that magnetic on the actual device itself, it works a lot better. So I hope at the end of this series that we've incorporated pretty much every single drill bit into this thing. And then maybe later down the line we'll start adding accessories as well. So a little while ago I actually bought some of this plasticine, and I want to use it in this project as well to model the grip, and then we can 3D scan that and import that into the CAD software, so we have an accurate indication of what we should make the grip look like and feel like as well. And I basically just mold it into something that's comfortable to hold, and also kind of reference the design of the original one. Ergonomics is one thing, but then actually having it be balanced in your hand as well is also quite important. And with normal drills, it kind of balances out because the heavy battery is underneath, right? In this case, we have the battery to the rear of the device, and I'm not sure if the handle is gonna be comfortable in that position. I think one issue with this is that it's right-handed only, right? So left-handed people are kind of out of the game here. Thinking of adding an extra bow here at the top so you can also latch it onto stuff or something. Adding that handle to the top can also really help with grip because it's actually hooked around your thumb, so to say. And then it's very difficult to drop essentially. You can just relax your hand and it will still hang on your finger, right? So after that plasticine is all modeled out, we take that to the 3D scanning station. You can use a caliper as well and create your own point cloud essentially, or tracing it and doing it that way. If you have an iPhone or an iPad Pro that also has LiDAR tech in there, you can also use a free app called 3D Scanner, I think, 3D Scanner app, and you can do it in that way. So for this design, I basically had to get rid of most of this stuff because Shaper 3D is very tricky in regards to chamfering stuff. As soon as you've chamfered something and it's in a weird position somehow, it's very difficult to undo that. And the only thing I could really keep was the holders for all of the electronics. So the drill itself, the trigger, and the battery holder. What you see me doing right here is just outlining everything with a pencil, all the information that we can't really recover, and then subtracting that. And then, we have a clean slate to work with. Did the same on the main body over there with the handle. And then I imported the 3D scan of the plasticine mold that we made. Created this little outline for the holder in the center. Removed some of the material at the back and also added these finger holders, so to say. And then also created this subsection for the palm over here, removing that about halfway. And then I go about, rounding over everything. And then I also came up with a puddle design in the center, otherwise it looks very two-dimensional. After that I start rounding over all of the joints. And this is kind of a process that usually I do after 3D printing it once, because after this point you can't really go back and change stuff very easily. The rest of the device I didn't really film how I created that, but it remains relatively similar to the other one. I just added this rounded centerpiece where the handle is held in place, and the front compartment holds all of the bit storage, And it also has like these vent holes which are pointing backwards so that it doesn't suck up all of the dust. So for this project I wanted to use a resin printer, and if you don't want to deal with the same issue that I had to deal with in this project, you might want to check out today's sponsor, PCBWay. They offer a lot of prototyping services from PCB production and assembly, CNC machining, sheet metal fabrication, injection molding, and of course also 3D printing. You simply upload a file, you get an instant quote for what it's going to cost, and they offer a variety of materials. So for a project like this, I really recommend choosing nylon, as nylon is quite like drop resistant, and a tool like this is going to be in quite a lot of like rugged situations. I printed the first EDC tool with them in nylon as well, and that turned out really awesome. So once this project is finished, I'm sending it off to them as well and printing it in nylon again, because the print service there is just really amazing. And yeah, definitely check them out. I left the link in the description down below. Special thanks to PCBWay for sponsoring today's video. So the prints came out looking like really amazing. I was really chuffed with the print quality. This is with a new 16K resin printer from Elegoo. We'll be featuring it in a video in more detail later down the line. And I was putting the drill together after 3D printing all of the components, right, because everything looked okay. And I noticed that everything was really tight, and at first I assumed that it was a difference between FDM printing and resin printing. You know, resin, the tolerances are a little bit better on resin, I believe. So I thought it was that again. But then I tried to input this magnet over here, and the gap for it was a full 2mm too short. There's something wrong with the printer, which basically shrunk everything, which really sucks. So I'm still a little bit unclear on what actually happened. I assume that it is my fault because I received a printer which wasn't released yet, and I selected a preset for it. Like, you know, you can choose like which printer do you have, and it wasn't in that list, so I chose the previous model of that printer, adjusted the resolution myself, and I didn't pre-check it. I didn't check like, is this accurate? So normally I wouldn't really put it together, but there's still quite a lot of things that we can learn from this model. So what I really like is the storage down here, which is just all the way around. And at the moment there's no magnets in there or anything, but it just looks really cool, and it's very accessible as well. So there are some things that I'd like to upgrade in the next variant before we print it again. Like, there needs to be some more room in the handle itself for all the cables to go, because it was quite a pain to get it all in there. And the handle itself, you know, when you adjust it into this configuration, I'm getting pinched a little bit by the casing over here. My fingers can't go in between that, so giving it, you know, a couple millimeters more room would be really nice. In this configuration it's really quite nice actually. Of course I wasn't actually able to test the drill in a real world situation, so I can't really verify if this is a valid way to design a drill, and there's probably a reason for it not being designed like this in the first place, right? But it's a fun project to, you know, figure out new stuff, figure out new design techniques and that kind of stuff. And it's not meant to be taken as like this is a replacement to your stuff. No, of course not. It's just like a fun project as a proof of concept again. After that I went back to the CAD program and redid some of the design, so I made some more room for the fingers to go, so to say, and I added some additional tool storage around the centerpiece, which initially I didn't want to do because I thought it would be very painful to, you know, unlock it so that you can move the handle, but I thought I'd give it a go. It seems so I needed more storage space on there anyway. I didn't really have any normal PLA laying around, so I did have this silk stuff which has two colors, and I printed it in that. It kind of looked like a Call of Duty skin applied to a drill, so I'm not entirely sure if the theme there works, but I thought it looked pretty okay. In terms of the build process, I did use these heated inserts, and I might have set the temperature a little bit too high because they were a little bit difficult to get in there. After attaching the rosette mount, I added this main bolt, which is M8, and it comes from the side of the handle, and that will be bolted into the main body of the design, so to say. So inside the main body there are some holders for these 50 by 10mm magnets, and those hold different bits in place and that kind of stuff. So in this case it holds that little choke, but this one wasn't strong enough to actually hold it properly. So in the next version I'll use the different magnets that I use for the other bits and stuff as well. The magnets that I used for those were these round ones, which are 10mm. I just shoved those into place by pressing it in and then moving the whole stack backwards a little bit. And sometimes I also put a magnet on the other side so they actually stay in there. And there's a bunch of these scattered through the entire build. Also added this little safety plate over there so that they don't snap off when you put the bits in. And then you can compress the two components into each other. I think the main problem I had with this project was I was trying to do this when I came back from a very long day of work. Wanted to publish the video on time, so to say, and I was cutting corners, didn't double check anything. plugged the battery in, pressed the trigger, and all of a sudden I saw some smoke emitting from the device. So I chucked the battery because I'm afraid that the lithium ion thing is going to explode. So it's definitely not the ending that I was hoping for with this project. I was hoping to showcase it in action and 3D print the little remaining parts where the bit storage would be as well. But at the end of the day, I think it's also important to showcase on YouTube that, you know, failing at projects is a pretty natural thing to do, and it shouldn't hold you back from making new things and trying stuff at least. Yeah, it does give a great indication for what it is at the moment and what it could be if the drill still functioned. So there was some concern about the little bits like falling out if you would drop it, or, you know, being really easy to fall out, but that's not the case. They're actually in there really tight, so I can show you here. As for the wiring over here, I would have put a sleeve around that so it looks a little bit cleaner. But the handle itself is actually quite functional. It doesn't like move when you push on it. It is a little bit loose though, so it does have a little bit of wiggle. But you can actually push it into a different position and it still stays in that spot, so to say. My initial idea was just to loosen it up and then move it into that spot, but it works by just forcing it as well. So in that regard, it was quite a success, so to say. So that was it for this video. I hope you enjoyed it, and I hope it gave you some inspiration for your own project. If it did, leave a like, leave a comment, and hopefully see you in the next one.